Section 3.2 deals with Rolle's theorem and the mean value theorem. Now these are a little wordy and they do require you to understand things about continuity and differentiability. So it's going to require a little bit of thought. The first theorem is Rolle's theorem, and it says that if f is continuous on the closed interval and differentiable on the open interval from a to b, now all that means is that it has to be continuous, including the endpoints of the interval, and the derivative has to exist, but not necessarily at the endpoints. That's usually a distinction we don't have to worry too much about. And it also has to be true that if f of a equals f of b, that means that the function values are equal at the endpoints, then we know that there has to be at least one x value, and your book always calls that x value c, in the interval from a to b, where f prime of c has to equal 0. So one more time, it has to be continuous, differentiable, and f of a has to equal f of b. If those three things are true, then there has to be at least one value in that interval where the first derivative is equal to 0. Another way of saying that is that if those three conditions are met, then there has to be a relative extremum somewhere in there, or a turning point. So for our first example, we're going to let the function f of x equal x to the fourth minus 2x squared. And we want to find all values of c in the interval from -2 to +2 that are guaranteed to us by Rolle's theorem. So if we're going to use Rolle's theorem on the interval from -2 to 2, we first have to convince ourselves of three things. Is it continuous? Do you guys believe it's continuous?
Yes.
Do you know why? It's a polynomial, and all polynomial functions are continuous. So anytime it's just your basic cubic, quartic, parabola, line, those are considered polynomial functions, and they are always continuous. So you believe it's continuous?
Yeah.
Okay. Do you believe it's differentiable?
Yes.
We know it's differentiable. Why? We can take the derivative of it, right? If we take the derivative, we get 4x cubed minus 4x, right? And there's nowhere in there that would be undefined. So we believe that it's differentiable. We also have to convince ourselves what? That f of a equals f of b. So we need to know, does f of -2 equal f of +2? And we can just plug in and check. If I plug -2 into the original, what do I get? -2 to the fourth is 16 minus 2 times 4, which is 8. So we get 8 if we plug in -2. Let's see if we get the same thing when we plug in +2. 2 to the fourth is minus 8. So are they equal?
Yes.
Yes. Okay, so we are convinced that all three of those conditions are met and that Rolle's theorem must apply. Now Rolle's theorem says that somewhere in there the first derivative has to equal 0, and they're just asking us to find where. So if we take the first derivative, we get 4x cubed minus 4x. We're going to set it equal to 0. We're just going to find all of the places between -2 and 2 that that's true. And those are called the c values that are guaranteed by Rolle's theorem. We factor out 4x, and we're left with x squared minus 1. And we see that 4x equals 0 and x squared minus 1 equals 0. We actually get 3 spots. We get 0, 1, and -1. Those are also called horizontal tangent lines. So those would be the places where there would be horizontal tangents. So that's all that Rolle's theorem is saying. It's telling you that you can find at least one, a minimum of one place, as long as these three conditions are met, where the first derivative equals 0. And it turns out it happened 3 times in that interval.